Hey guys, and welcome back to Gregtech New Horizons. We have lots to do today. I would like to finally be able to flesh out our Applied Energistics system and actually implement some autocrafting, now that we have access to epoxy and therefore cheaper circuits. Last episode we added these 4 LCRs along with a bunch of machines over there to handle the creation of epoxy. Between the episodes I also added this one on the end for iron 3 chloride, something else that's used in the circuits, and we also got our clean room moved over. Although I kind of cheated a bit last episode and we don't really have this hooked up. I was just powering it with batteries. So that's going to have to change today. So yes, first thing on the agenda is to batch craft a whole lot of circuits for all the machines we're going to be crafting over there. We'll also probably take some from our old base, but this is not going to be enough. Let's see how many we end up with at the end of this episode. Hello zombies. Oh, these guys are fast. Look at them. Okay, that's enough oh, there's another one back there. That's enough messing about, let's get crafting. Hey, you. So, we are back here on the moon, and we haven't been here in a while, eh? We are here to collect some more salt water for chlorine with our oil drilling rigs. And we also got both of the miners placed. I wanted to come here mainly for bauxite actually, since we need a lot more titanium. But this was just meant to be a quick trip. We'll come back and check on all the miners and the oil rig later on. So for now we'll place the output of the ender tank next to these electrolyzers, which we set up last episode. It's actually really nice to give the ender tank a bigger buffer as well. Look at that, 256 millibuckets. So yeah, all of this is going to be turned into chlorine for us, which we use in many different processes around the base now. But let me show you guys what I've been working on the last couple of hours. So I've more or less completely redesigned this room for on-demand processing. A lot of these machines we already had, like these forming presses for the AE2 processors. The power setup here actually took the longest, so basically what we're doing is we're actually using EU P2P channels. So underneath the room we have this Gregtech EU P2P, which goes into the extreme transformer. That transforms it from IV to EV, into an extreme voltage battery buffer, and then into 8X aluminium cable, and then down to 2 HV high amp transformers, which will output 16 amps of HV power. The input for this thing is down next to our combustion engine. So this is our main IV power line here, and this is the input of the P2P we saw over there. Although after doing some calculations, it's actually not worth doing this. Whenever you send energy through the P2P like that, we actually lose 5%. And because it's a flat 5%, the higher tier of energy you go, the less worth it is. Unless you're sending it like thousands and thousands of blocks. It's maybe even worth moving this P2P to the EV line, and moving the energy as EV instead. So just based on some rough calculations, we're actually losing around 400 EU, transferring it this amount of distance. Whereas if we were to extend this platinum cable out, it would only be losing about 100 or so. So I think I'm actually going to switch that out. Anyway, for right now, let's continue with the automations here. This is the fun part. This is probably my favourite part of any pack, is doing this. So the setups that we have here, we're just sending all the items in and out via the interface. And we have our Applied Energistics 2 processing patterns inside. So I did batchcraft around a stack and a half of these things. A lot of them were used for the Lapitronic energy crystals though, which again is probably overkill for the setup we have there. But it's okay, we're going to need them in very large quantities later on, as we use these to laser engrave into the engraved Lapitron chips, and these are used for the IV power storage, and we need 24 per energy orb. Anyways, right now we have the capabilities to create plates, circuit plates, all of the Applied Energistics processors, which we're actually missing patterns for. We can do rods, and we can do wires. One of the machines we used most often is the extruder, and look at all the presses and molds we have for these things. And as I said earlier, I think we're going to be doing one pair, because there's no way to pipe in and out these extruder shapes. I think there's more. Oh yeah, like look at all of these are unique as well. Well, I know we don't want to do rotors this way, since if we fluid solidify it from the fluid, we actually save like 0.4 ingots, something like that. So yeah, we'll avoid doing that in the extruder. We don't need the wire one either. We can do this in the wire mill. Ingots, we don't need that, obviously. Plates, we don't need that. We can do that in the bending machine. Screws, we can do another way. The anvil, we're not going to bother automating that one. I don't think we need block either. I think these 9 is what we're going to want. So 9 extruders. Oh boy, this is getting expensive. And we've just started this as well. Oh no way, the extruder takes canthal wire. 4x canthal wire. We don't have much canthal, do we? Well, I guess we're making up some more canthal then. This should be pretty fast with the overclocked blast furnaces we have. Yeah, only 11 seconds with the setup we have here. So the idea with this room is we want to have machines which will autocraft pretty much any material that we want. It's not going to be possible for us to automate everything because we're limited by the HV machines in some cases. But one of the trickiest things to do is actually handle the fluids. So most of the assembling machine recipes do require fluids. And again, we'll want one assembling machine per fluid type. So there's things like polyethylene, silicon rubber. Actually, what else is there? Ah, that's right. Solder and alloy is the other one. So yeah, there's 5 in total that we need for now. There's a few other fluids that we can use in assemblers, but those are kind of not used quite as frequently, so we'll stick with these 5 to begin with. And obviously we do need an interface per machine as well, which takes 12 titanium each, which is the reason I took a little trip back to the moon. We have 168, which I'm hoping should last us today. Let's see if we're able to get the other 4 assembling machines we need though. Obviously we have one over set up already. Where's 1? There's 2. We're out of robot arms. And we're out of pistons. Oh, we can actually craft these. Okay, there's 2 more. It's 2 per assembly machine, so we need a few more robot arms. Oh, we're actually out of gold cable. Well, in that case, rather than just batch crafting manually again, let's set up at least one of these assemblers. This guy is going to be... Wait, how was I naming it before? It was assembler? Yeah. Assembler HV rubber. No, circuit number, then rubber. Output to the bottom. Enable auto output. And allow input from output side. Obviously, we're going to need... Whoa. Well, it's thundering outside. That was very loud, actually. So obviously we need to automate rubber as well, which means we need a chemical reactor, sulfur dust, and raw rubber dust. So do we have an HV chemical reactor? Wait, this one's HV, right? Although that being said, I don't think we really need to do HV for rubber. I think we can get away with LV and we'll just keep it passively being produced. Same with the rest of the fluid extractors, actually. I think we're going to do them all at MV. And we'll just have them fed in by fluid P2P. And that means that we can save a little bit of space over here for the HV machines. And we can do MV, I'm thinking probably over there. Alright, so we got the infrastructure set up here for passive fluid automation. Although this machine isn't working, why not? Did I forget to plug it in again? So yeah, we set up the infrastructure, we have our transformers and things down here. We're again pulling from the EV line. I wanted to do it over here just to keep all the MV machines together. There's no point in going HV for things like this, which are completely passive. Oh, there we go. Took a little while for that thing. And we'll need some mufflers. Anyways, for the time being, since we don't have infinite redstone, I mean, we have a lot of redstone. There's like 10,000 odd redstone we have. We're just going to fill this drawer manually. Although eventually we'll hook it up to an interface and have this automatically supplied. We're just not going to go through that much redstone at the moment. Same for the rubber as well. We don't really have raw rubber dust automated. And to be honest, I'm not really sure the best way to go about doing that. Oh, that's right, we can do isoprene. Yeah, we can get isoprene from propene. Mix that with oxygen and we get raw rubber dust, and then sulfur obviously comes from the nether and other ore veins. But that's something we'll set up later. We have a huge backlog of both of these things. So we're just pulling in via a conveyor module on the top. That outputs our fluid. I've left a space for a tank here if we need it in the future. But for now we just use the internal buffer of the machine, extract on brown, and this we're going to hook up to our fluid P2P network. We were actually out of channels on this line, so I had to move the P2P slightly closer to where this intersection is and then place a dense cable. That allows us to get 8 channels on each of these purple flux cables here. So right here we can place the P2P. It should be on E27 as our network number. Hook this up with a fluid conduit and this should be all insert on brown. Oh, what am I doing here? And then if we come over to our assembling machines here, I did actually craft a few more. We can hook up the other fluid P2P on this side somewhere. Come up with our Fluix cable, and we can put the P2P right here. This will be extract on brown. Link it to E27, and now we just have to filter the inserts of these machines here. So on this top side of the assembling machine, we want to insert on brown channel for redstone, which will keep the internal buffer of redstone full so long as we have redstone in that drawer over there. Same with the rubber here, we can filter the insert on this one. Nice, so that should stay full of rubber. It's probably making more, which is why it stopped. I hope that's the case anyway. Yeah, it's just a slow chemical reactor. That's okay, it's passive. So we got the redstone, we got rubber, we need solder and alloy as well. So if we look at the recipe for solder and alloy, this obviously is an alloy, judging by the name, of antimony and tin. So what we're going to do here is have a dedicated alloy smelter for this. And I have actually just been disassembling some of these MV machines to get the parts back. There's not really much of a use for most of these things anymore since we have the higher tier, and we can make use of these parts again. I love this disassembling machine. So yeah, we'll make a dedicated MV alloy smelter for this, and we'll have the alloy smelter pointing into the fluid extractor. Make sure we hook these up this time. And then again, for now, since we don't have infinite antimony or tin, we're just going to hook up a drawer here which we manually fill with both of these items. We're kind of running a little bit low on tin, but I did set up one of the miners on the moon there for tin, so we should get quite a lot of it when we go back there. Solder and alloy is also used as the fluid for circuit production, which we'll need again in the clean room, which is why we want to hook up to this P2P system, so that we can feed it over to those assembling machines over there, and also the circuit assembling machines in the clean room. And again, we just hook it up to our fluid P2P network. Cool, so now we're almost passively producing solder and alloy ingots. Yep, there we go. Again, we'll just use the internal buffer of the machine since we don't need to buffer that much of this fluid. And then we come over here to our assembling machines, filter the insert, name the interface, and we're done. So this is used in things like the illuminated panel for Applied Energistics. It's used in a lot of the covers as well, activity covers, machine controllers, all that stuff. It's not used too frequently, but it's going to be nice to have it just here for when we need it. So the last two here, the polyethylene and the PVC, probably the two most, well, the polyethylene is probably the most important one since we use it in all the machine halls, is actually still both being made here at our old base. In these two LCRs, we're making polyethylene in this one and PVC in this one. So we have planned out a little space here for it to be moved. We're going to put polyethylene here, vinyl chloride, polyvinyl chloride here, and then our silicon rubber. But we're not going to do that right now. I've also laid out some space here for Teflon, or go to hell. Polytetrafluoroethylene is going to be sitting right here, but we're still yet to hook that up, and we don't have quite enough materials, I don't think, to be able to craft the LCRs for that. Let us see actually if we can get any more of these HV extruders. A lot of the Canthal should have finished by now. Oh, and we're actually out of electric motors because of the Electrum. All the electrotine we've been processing is coming in very, very handy right now. We have almost 600 Electrum, plus we have the pattern here for Electrum wire, so I don't know, make me like 256. Oh, this is such a good feeling. It took like 400 hours to get this, but finally we can just request stuff. Looks like we're running a little bit low on stainless steel rods as well. It's almost time for another batch of stainless steel. But we can now add the extruder recipe for the stainless steel rod in one of the two extruders that we currently have. And we'll obviously have to give all of these things channels. So I've tried to route the cables in the most sensible way. So this line that you can see right here leads straight from the output of our subnet. And then we have two P2P channels, each of which can handle 32 channels coming out of here. And we'll just split the room in two. So all of this side will be handled by this P2P, and the left side will be handled by these ones here. So the first extruder here is going to be for rods. And now we're out of 2x silver cable, but that's not a problem. We just add the processing pattern for this. We don't need the pulp in the recipe though. There is also the issue of how do we get blank patterns. This is something else we'll definitely want to automate. Of course we can't do the molecular assemblers recipes yet. Any crafting recipe requires one of these things, and this is one EV machine each, so that ain't happening for a while. But we can do things like the alloy smelter for quartz glass, the glowstone plates we can already make, and Certus quartz is from ore processing, which we still have to hook up. But we have a decent amount left at our old base, along with some in our AE system here. But after a very, very expensive investment, this should be the last two extruders that we need. And now we should have one available for every important extruder shape here. We still need the interfaces though, of course. On that front though, for the titanium, I found that we actually had like 2000 odd ilmenite dust, which we can smelt 9 to 4 for rutile, and rutile is 1 to 1 with titanium. So I sent a bunch of that through the blast furnace. I just didn't want to run 2 of these things at once, while also charging up some batteries over there. So we turn this on. This should start blasting us some titanium, and we should be able to get the interfaces with this, so long as we have the gold. But yeah, I'm going to take some time and craft up some of the other machines that we need, like the alloy smelters. We'll also need some more bending machines. We only have the one here for circuit 1. Probably a chemical reactor. And then we'll also move over some of these ones as well, like the mixer and the autoclave. I think we'll need a few mixers though, since there's different circuit numbers. Yeah, something like this. I'm getting a bit too carried away with this. I'm having so much fun with this. Anyways, we got most of our machines moved over now. The vast majority of them are hooked up to Applied Energistics. I think this wall looks the craziest, to be honest. I'm not such a big fan of this flat wall. Just the fact that we have a big box here, but... We'll clean up the aesthetics at a later stage. The most important part is it's functional. So some of the things isn't connected, like for example this disassembler, we just use this manually. Same with the macerator, although that will probably end up getting an interface at some point. The chemical bath, the electrolyzer and the autoclave we don't have hooked up yet. But everything else we have given an interface. I've made 2 mixers here, I'm just in the process of automating vibrant alloy dust. We have an alloy smelter, a polarizer, 2 bending machines. I actually forgot the interface for the second one. And in fact, I think we need 3 of these bending machines. We got the lathe, which was here before. We have 2 wire mills. I accidentally crafted an extra one. We may end up using this or just disassembling it, I'm not sure. Over here, we have a way to produce rotors. So earlier on, I mentioned that we could save like 0.4 ingots by making this in the fluid solidifier. So the way this thing works is, if it's slightly different to the rest of them. If we want to, for example, automate the stainless steel rotor. So the ratio I've been doing is 17 ingots to 4 rotors. And that applies for any type of material as well. And we have everything named here in the interface terminal, so this just goes in our fluid solidifier for rotors. And when we request a pattern, what's going to happen is the interface will send the ingots into the fluid extractor. That is fluid auto output to the top, into the fluid solidifier, and then the item conduit puts it back in the interface to complete the craft. So that's just a very simple way to handle the recipe with 2 crafts. I started filling out some of the other patterns here, but a lot of them are still empty. We're just going to fill them as we need them. So you're probably aware that the vibrant alloy recipe is very nested, and does require 2 circuit numbers that I can see, other than this thing, but we haven't unlocked the ability to do this yet. But honestly, it's super easy now that we have Applied Energistics. We just have to note the circuit number, so this is circuit 1, encode the pattern, and this goes in mixer HV1. Easy. Same for black bronze. This is also circuit 1, done. And I think that's the bottom of the line as well. So we should just be able to request vibrant alloy dust. We're out of blaze powder, and it's another blood moon. Wait, I just had a blood moon. I swear there was literally just a blood moon. Anyways, we are farming blaze here. Now once the Applied Energistics finds the recipe again. We don't have all of this place chunk loaded, which is why sometimes it takes a while when we exit and enter the void for things to load again. But yeah, now we should be able to just straight up request vibrant alloy, which is something we're going to need for our next project today. We are going to need some more ender fluid conduits. We have very few left, which takes PTFE. For now, we just keep batch crafting this. But before we start our next project, it's time to take our little trip back to the moon. Always takes so long to get here as well. I mean, I guess we are going to another planet. Okay, let's see how the first miner is doing. Looks like it has finished. A lot of this stuff was already in here, but this is supposed to be a tin vein. Yeah, cassiterite and tin. Wait a second, did I put this on an... Did we already mine this out previously? I think that might be the case. Because this hole was already dug to bed. Oh no. Well, that was a big waste. Let's make sure we remove this marker from the map. I feel a bit silly for that actually. Let's check the fluid drilling rig. I think that must have finished by now. Oh, it's still going. We are almost out of high octane gasoline for this though. Let's make sure we refill the oxygen. And we fly out and check the other miner, which is a couple of 100 blocks this way. This is the main one we were after for bauxite. Aha, that's what we want to see. Look at all that bauxite. Oh, and this one has plenty of high octane gasoline left. Alright, so we give the fuel to the oil rig and we'll come back for this later on. Okay, so I started to process some of the bauxite and aluminium we got. And the next project I would like to work on today is the automation of circuits. So similar to our machines over there, I'd like to be able to make circuits requestable. We're not going to make them passive yet, since obviously we don't have passive resources. And we're still using the SMDs, we're not able to do the advanced system on chips yet. But before we do anything, we have to fix a bit of this mess down here. So I did have a go at sort of hooking this up, but I think I'm going to redo it, to be honest. And if we're going to have automation in here, it also means that we need Applied Energistics connections through here. And obviously we can't just break a hole in the clean room, otherwise it makes it dirty, so we need another solution for that. And that is going to come in the form of this wireless connector and wireless setup kit. It looks like a fairly easy recipe. Yeah, actually nothing too bad, this is just HV circuits. Ender Eye I'm not sure we're going to have, but we can always buy it from the quest book. Oh, you know something we didn't make over in the new base actually is a compressor. Yeah, I guess we're doing it at LV then. We do have a cutting machine though, somewhere. I'm still not used to this new room where all the machines are. Ah, there it is there. And we have this automatically being supplied lubricant, which we are creating somewhere over there. Comes out of the same fluid P2P as the rest of these ones. That allows us to make the Ender Eye plates, which allows us to craft the wireless setup kit. I assume this is how you link the two devices. And 2 wireless connectors. Oh, we're short a receiver here. Oh, we're short a lot of things here. Alright, so let's find out how exactly these things work. Do we just right click both of them? Oh, well that was easy. Well, I'm assuming that means that we can just hook up one on the outside, one on the inside, and that's how we're going to get our Applied Energistics connection through there. But before we do that, we need to handle the power situation and place all of the machines. So in the shell of where our clean room used to be in the old base, there is still a few machines scattered here. Although I think this time we're going to lay it out slightly differently to what we have here. Alright, it has been a while, but let me present our new clean room. Look at this thing. So this took me a few tries to get right, and truthfully I still haven't tested this fully. We're waiting on this getting up to efficiency again. But we'll start outside with the power situation, so I did manage to fix this up actually. I'm quite pleased with the way this turned out. So we do have 3 tiers of power going in here. We have MV, HV and EV power going inside the clean room. So we're taking from our main platinum cable here, which is IV, transforming down to EV, and then this is on pink. The EV is buffered into this battery buffer, and right above this battery buffer, I don't really want to break this block, but we have the cable diodes up there, which can accept the 4 amps of power. And it's the same for each of these. We're stepping down to HV and then into a battery buffer, stepping down to MV into a battery buffer. Only above this transformer actually is the MV energy hatch for the clean room itself. So all of those cable diodes point into these cables here, which actually should be sprayed technically. So this one is HV, then we have EV, this should be plugged in here as well. And on the left here is MV. Alright, so for each tier of machine we have the laser engraver, cutting machine and circuit assembling machine. Starting at MV, same for HV, same for EV. Only on the end here we have an extra EV assembling machine. So I don't remember exactly what the recipe we need for the clean room inside the assembling machine. I just know we need one here, so yeah, it's here. And we also have a chemical reactor here at EV. This chemical reactor is meant for the nano processors we looked at last episode. Or no, the nano wafers. We need an EV chemical reactor inside the clean room with molten glowstone, central processing units and raw carbon fibers. So that is what this thing is for. I decided not to hook up the LV stuff since it wasn't really necessary. We can do LV and MV circuits in any one of these, to be honest. So just behind this blue alloy cable is our connection through to the Applied Energistics system, which is hooked up 1 block through the wall connected to this wireless connector. And this goes on dense cable and is connected to our P2P, which sits right around here. Coming out of this thing we have 1 dense conduit there, which is important actually since we have 9 channels being used inside the clean room. I shouldn't have broke that cable there, and we need to recolor that thing. So yeah, there is 9 channels. There is 8 interfaces and also 1 P2P for fluids. So the 8 interfaces are on each of these machines down the bottom and also on the laser engravers up top. The P2P is extract on brown, which provides all of the cutting machines with lubricant. The lubricant we are making over here in this brewery. And you remember earlier on we set up solder and alloy? Well, that should be filtered in these circuit assembly machines, although I think we are out of tin. That little mistake on the moon did not help us out today. We do have some spare though, in one of these chests. Yeah, we've got some solder and alloy we can work with today. So in theory, these should stay full of solder and alloy. So let's work our way up here and try to make LV circuits requestable. At this point in the game, all we really need to produce is the microprocessor. We don't need to make the electronic circuits anymore or the integrated logics. Actually, hold on, can we get system on chips yet? No, we need Naquada, which I think technically we can get, but we're not going to go that far yet. Let's just stick with the same SMD recipe here. So we have been batch crafting a bunch of SMDs here, which we'll use today. Although I think for most of these actually, we can set up assembler recipes. I think we have all the machines to be able to put in patterns for all of this, but I'll do that between episodes. For now, we just use the backlog and we'll stick all of this in our drives. Assuming it all actually fits in the drives. Although I don't think I actually showed this, but check this out. We got 4 16K storage cells from one loot bag, which is absolutely insane. Anyways, yes, the microprocessors. So there is 33 recipes of LV circuits. We want this one here. So other than the SMDs, we are going to need a recipe for fine copper wire, which we can do in our wire mill. I guess we will need the second wire mill sooner or later. This is going to fill up pretty quickly. I know we have the expansion cards, but even with the expansion cards, I think we'll need more than one. So other than that, we also need the plastic circuit boards, which takes our iron 3 chloride. This is the fluid that we're making over here, next to epoxy. I set this up between episodes. So we do have a spare HV chemical reactor here. This should be very easy to automate. All we need is an interface. Hook up some fluid conduit on top. Set the insert filter for iron 3, which should fill it to full. That LCR should turn on by now. This is going to be chemical reactor, HV, iron 3. So I hope you can see how important all of this infrastructure is by now. Like, this is just so easy to add, now that we have the materials. But I mean, it's still not cheap to do, but it's way, way worth it. All we need now is a recipe for this thing. Oh, that's right, we need the plastic boards as well, which takes sulfuric acid. Oh, and we don't have another chemical reactor. We can make another one though. Okay, let me hook this up for sulfuric acid. Actually, nope, we're not doing that. We're out of titanium completely. So we can't get the interface for this. We do have like, what, 4 boards we can use? So we can get 4 plastic circuit. No, we can't. We're missing copper foil. That's just going to be a recipe. I think we have the bending machine already. Okay, so now all we need to do actually is add this encoded pattern for the circuit into this interface. Although I didn't actually check, are these devices online? I don't actually think there's any way to tell, is there? Maybe let's rename it and see if it shows in the interface terminal. Oh, it does! Look at that! Oh, nice. Okay, so we should be able to actually just request microprocessors now. We have 6 already, let's request 1 more. Oh, I didn't set the output on this thing though. We need to allow input from output side and set the item auto output on this. I think it worked. Yes, we have 8 of these things. Awesome. We have automated circuits. Nice. So it's going to be the exact same process for the MV tier. This is almost the same materials, only instead of fine copper wire, it's fine red alloy wire. Oh, you know what? Actually, I forgot about these drawers that we had at our old base. Oh, there's so many mobs around here. Look at this spider here. Yeah, we actually have loads and loads of circuit boards. I forgot I batch crafted a lot of these things. Alright, so I encoded the recipe for the MV. We also do want blocking mode on all of these things. So blocking mode will prevent the interface from sending any items to a machine if it already has items in its internal buffer. Let's see if we can request the MV as well. We have 6 right now, we have 7. Nice. So the other part for these MV and LV circuits we kind of skipped over a bit is the central processing units, which is where our laser engravers come into play. I think they both take central processing units for these, which probably means having 3 of these things is way overkill. We could have probably just got away with this one setup here. And in the future, in fact, we may even remove these HV and MV machines. But they're there now, so we keep them there. Anyways, to automate the central processing units is actually going to be similar to the way we done voters over there, where we're going to have to give it a custom recipe, so we'll want the central processing units as the output. Only for the inputs we want to set as the unprocessed wafers, in this case glowstone doped. And I guess we'll specify the HV one as our central processing unit creation. Since we need to do 1 laser engraver per lens type, there's no way, it's a bit like the extruder shapes, there's no way for us to take these out automatically. So this recipe will go in here, it's going to send the wafer into here, be laser engraved, and then we want this to automatically send its contents to the cutting machine. And then from the cutting machine, I actually have a little item conduit back here. So we're extracting it on blue, and that will send it back into the interface to complete the craft. So that should work in theory if we request one of these things. Let's do 8. It might take a little bit since this process is quite slow. Let's see if it works. Oh, it is laser engraving, okay. Make sure we set item auto output. I always forget this thing. That and plugging in the machines. Okay, 45 seconds. It goes to the cutting machine. And we have no power because I didn't plug this in. And this should get sent back to the interface. Nice. Awesome. Alright, well this means that we have LV and MV circuits fully requestable now. We are almost there for the nanos, but this is going to take a little bit more processing with the epoxy we set up. Nothing too difficult though, it's just a few more machines and titanium which we don't have. So yeah, I think we're going to wrap things up here. This has been quite a lot of progression, well not progression but sideways progression. We got a lot of infrastructure set up today, which I'm really pleased about. So yeah, that is going to do us today. Thank you so much for watching, and I'll see you all soon for some more Gregtech New Horizons.